In case of car, M0 and M1 is 1. And this is true for arbitrary system with two types, two coefficients. Okay? So I'm going to do the following. Let's see, what is phi naught equal to? Now, here is the time index, okay? This is t. So this is t. Look at this equation and tell me what is phi naught equal to. Plug phi of 0 to here. What do I get? M naught, phi naught, right? And 0, phi of 0. Do we have this? Phi of minus 1. What is phi of minus 1? 0. So you only 1/3. Okay? What does phi of 1/2 look like? What I'm trying to do here is I'm trying to find solution for 0, 1/2, 1/4, and so on. If you have all that, you can actually plot the curve, right? And that's how the computer is finding those points. Okay? What is phi of 1/2 equal to? M0 phi of 1. Phi of 1 is 0. Right? It's only from 0 to 1. Yeah. That doesn't include 1. Because it already includes 0. Okay? We have only this term. M1 of phi of 0. Let's do one more row and see what's going on. Phi of 1. What does phi of a quarter equal to? A quarter, M0, phi of half. And if I plug this one in here, what do I get? M0, M1, phi of 0. Okay? Or 3 of 3/4. 3/4 in between half, that's 0. It'll be M1. 3 of 3/4, that's 3/2, that's 1/2. Right? Be 1/2, which is M1 and 1 phi of 0. So let's see what's going on here. Let me discuss it with you, right? So I start with time 0. This is 1. I look at 1/2. And 1/2 all depends on time 0. And I look at 1/4. 3/4. What depends on 0 and 1/2? I mean, it depends on 1/2, but then you can convert it back to depend on 0. Okay? Now let's do one more and see what's going on. Let's do phi of 3/8. Now, then what's the next step? The next step is getting 1/8, right? 3/8, 5/8, 7/8. And so on and so forth. Okay? So that's how you do it. That's basically how you compute this in computer, right? You start 1 point, you find 1/2, and then you have 1/4, and you have an 8 and 16 and so on and so forth. Depends on how many, what is the resolution? You're going to start at 1/8, that's what you have. But that's what you plot anyway, right? You plot this point on computer. You don't plot 116 and 3/8. Right? We plot all of this point. Okay, so that's the process. The process goes from 0 to a half, to a quarter, to an 8, and so on. So the next thing I'm going to do is going 1/8, 3/8, 5/8, and 7/8, which is too much. let's look at only 3/8 for now. What is field 3/8 equal to? It will be M0 field 3/4, right? The M0 field 3/4. Which is what? It's right there, right? M0, M1, M1 field 0. Okay, tell me how to find phi of 7/8 without knowing anything. Who can see the pattern? Phi of 7/15 or 16, sorry. Equal to okay, so you guys see it, right? What is 3/8 in binary? Tell me the binary point. 0, 1, 1. Right? This is 0.5. Okay? So that's 0, 1, 1 is 3/8. That's 1/2. That's a quarter, that's an 8. 3/8 is a quarter plus an 8. That's 3/8. 0, 1, 1. Okay? What is 7/8 in binary?
1, 1,
1, 1, 1. So, and 1, and 1, and 1. What is 7/16 in binary? 0, 1, 1, 1. So M0 and 1, and 1, and 1. Okay? You can prove that's the pattern you want to do. Okay? As long as you can write it this way. And it's easy to do it if you have two-tap system. Okay? So for two-tap system, I know how to generate this on computer. It's very easy, right? I mean, programming computer is trivial. Okay? You know M0, you know M1. That's all you have to know. You start out with phi of 0 is 1. That's your initial condition. Okay? And you go stage by stage. The first resolution is 1/2 resolution. Right? Next one is 1/4, 1/8, and so on and so forth. Doesn't matter, you know, how far you want to go to. You know, you want to go to 10, 2 to the 10. You know exactly how to compute this. Got that? So the only thing I have to do next is, if I have a longer length filter, right? Let's say length, you know, 5 or 6. I need to somehow write it in this form. When I can do this, I'm done. Okay? Actually, this is the order 5. 5 is, this is 1, right? So that's the stopping point. Okay? So this means that I have 0, 1, 2, 3, 4, 5. That's what I meant by 10 to 5. Remember the first step that we have here is we identify the integer point, the initial point, right? And here, what do we have? This is 0 to 5. Those is your first resolution. It's on integer point, right? And then if you so that's the first step. And then the next iteration in yellow, in here. Let's call it blue, okay? 1/2 blue. It's actually 1/2, 3/2, and so on. Okay? So that's what we have. So let's look at the equation, right? P of t is 2 summation h of k, 3 of 2t minus 10. So here is, you have one point only. So that's a scalar point. If you have 5